question here. Palindrome permutation. So given a string, write a function to check if it is a permutation of a palindrome. So a palindrome is a word or phrase that is the same forward and backward. A permutation is arrangement of letters. So what does it mean? So let's take example. So for example, we have a word. Well, let's first say what's a palindrome. So an example will be taco cat, right? So taco cat, if you read it forward, is gonna be taco cat, but if you read it backward, it's still taco cat, right? So this is what's called a palindrome. So if I have an input string of any permutation of that, for example, I have a TACT, COA, this will be a permutation of the letters used in the previous palindrome, right? So if the input is this, it's going to return true. Hopefully that makes sense. So how do we approach this problem? I think first we can do is we can, well, let's first talk about what's the palindrome. A palindrome, just think about it. Let's go back to the example we had before. So taco cat, right? So in order for a string to be a palindrome, just think about it. If in this case it has how many characters? It has 7 characters. So that's an odd number. So basically, if you take the middle character, right? And then the left side will be a mirror of the right side, right? So in other words, if there's a letter C on the left, there has to be a letter C on the right. So with that being said, so there has to be only, so if you take away the middle character, the rest of the character, for each character, it has to be even count, right? Because if there's a one character on the left, there has to be one on the right. So each character has to be of even count. And lastly, if you add the middle character, it's going to be the total count for each character will have to be at most 1 odd. Hopefully that makes sense, right? So let me take another example. So if I have TAC, CAT. So in this example, we have an even number of characters in this string, and we don't have the middle character as before. So in this case, for C, it appeared twice, A appeared twice, and T appeared twice. So for each character, it has an even number of appearances in this string. So it's fair to say that for to be a permutation of a palindrome, a string can have no more than one character that is odd, right? So let me repeat that again. So for a string to be a permutation of a palindrome, there has to be no more than one character that is odd. So think about it. So if I change this middle character to C, so the only character whose count is odd in this case will be C, and it has to be the middle character, right? So if A has a odd number of characters, we have an odd number of A, say we have one more A, where would you fit it? You cannot fit it on the left or right because it will break the balance. So there has to be no more than one character whose count is odd. All right, so if that makes sense, this will be very, very straightforward because we can first build a what we call a frequency table. A frequency table is basically we have an integer array and of for example of length 26, and each spot in this array will be holding the count for each letter, right? So and at the end, we're just gonna check and loop through all the counts in this array just to make sure there has to be no more than one odd number. So hopefully that makes sense. All right. So if that makes sense, let's start coding right now. So first we're gonna be building the frequency table, right? So it's gonna return a integer array. So let's just say build frequency table. All right, the input is going to be a string. First we have to define the length. So let's just call the result is equal to integer array of 26. Or instead of 26, you can say the letter Z minus the letter A plus 1. Why can we do that? Because this character in Java, it can return the number representation of this character in the ask table. So what's the ask table? We talked about ask table before, but let me refresh your memory again. So basically, a ask table here has a total of 128. It starts with 0, has 128 numbers, and each number will be corresponding to a letter. For example, letter A corresponds to number 97, letter S corresponds to number 115, and so forth. So basically, letter Z will be basically returning letter 122, right? So and you can pretty much tell that it goes in order from A to Z. So it goes from 97 to 122. So if you do the math, right? So 122 minus 97, that's 25, and plus 1, that's 26. So there's a total of 26 letters here in the range of 97 and 122. So with that in mind, this will equal to 22, and you can directly use the number 26. You can directly use the number 26, but I prefer to use it this way so that it's more clear. We're making the integer array from the range A to Z. Okay. So next, we're gonna populate this integer array. First, we have to loop through the string, right? So we have to change it, convert it into a character array. So we're gonna do a for loop. Each character in input string dot to character array, and this method is going to convert this input to a character array. And next, I'm going to say that the position in this frequency table, the result, right? So will be the, for example, will be the position for character C. So that's going to be, so if you think about it, right? So position 0 will be letter A, and position 1 will be letter B. So how do we get to position 1? Just the B minus A, right? So in this case, the position for character C is basically going to be, the result, the spot number will be basically C minus A, right? So this is the spot, and we're gonna do an increment so that this will keep track of a count for all occurrences of character A in the string input. Okay, and last, we're basically going to return the result. In this way, just maybe 4 or 5 lines of code, we build this frequency table that stores the number of occurrences of each character in this string input. So next, let's write our main logic here. I'm gonna say Boolean is palindrome. All right, so this again takes an input of string, and so here, let's see. So we're gonna first have to do. Let's start with the for loop then. So, right. So we're basically going to first populate this frequency table. So I'm gonna say the integer array frequency is equal to build frequency table, and this takes the input as argument. So okay, so now we have the frequency table populated. I need to loop through the frequency table and to just make sure there's has to be no more than one odd number in this frequency table, right? So again, we're going to be using a for loop for each integer, let's say I, in the frequency table. We're going to check if it's odd or not. Just remember, what if we have two odd numbers? So this whole function will have to return false, right? So if we just said if it has more than one, then it's not a permutation of a palindrome. So let's keep track, use a variable, Boolean variable called odd found. This will be initialized to false. This will keep track of whether we have encountered a odd number already. So again here, for each integer in the frequency table, we're gonna say if this integer mod 2 is equal to 1. So divided by 2 has a remainder of 1. That means this is an odd number. So in that case, we're going to say odd found is equal to true. Now think about it. Before we set odd found is equal to true, what if there's already an odd number found, right? So in that case, let's say if odd found, so that means there's already an odd number in this frequency table. In that case, we're going to return, the whole function will return false. That means it's not a permutation of a palindrome. And again, lastly, if we loop through everything and there is only one, it still returns true, and it hasn't returned false, that means there's only no more than one odd number in this frequency table. So lastly, we're going to return true. Okay. So next let's take this in an IDE and run it. Make sure if it works. So let me paste it here. Okay, looks like it doesn't like this. All right, I'm just gonna say 26. Oh, sorry, that's why I have to use a new. I could use this, right? Just gonna have to add the new here. Yeah, there we go. All right, so let's make this static so that we can make them both static and call them directly here in the main method. So I'm gonna say system dot, gonna print out the result here. Is palindrome dot is palindrome. Let's put the input string here, what we had used before. So taco cat. Okay, so this is going to return true. Let me do another example here. Let me do a do an even number. I'm going to remove the middle character here. This is also going to return true. And if I just add one more here, say add an A here, this is going to return false. Okay, so that's the expected result. Let's run this. And yes, this matches what we expect. Time complexity of this algorithm. So this is pretty straightforward. It's going to be a big O of n, where n is the length of the input string, because we do have to go through each character in the string. So the longer the string is, the more time it's going to take. So there's in this way, I mean, this algorithm, there's no way we can get rid of that. We do have to go through each and every character in this string array.